Welcome back to the shrine. One of the perennial problems with this CNC of mine is that it has a CAN bus problem, and this thing has been sitting here for 3.5 years. I didn't make a chip with it. First because I had other priorities, but I also had a couple problems. So you can see when I turn it on, it says input output nodes found do not match nodes specified as installed. So that is a typical message rubbing it into your face that something is wrong. So what we're going to do is try to figure out what's wrong. So watch this, DSP25 motion control, 2 nodes detected. Okay, so remember that, 2 nodes. So we're gonna go and turn on the servos, home the machine. Okay, she's homing the Z. You can see the Z is moving up and down. Now she's moving the Y. It's moving in and out, and now it's gonna be the X. Okay, so homing sequence is done. So at this point I can go to hand wheel and turn on Z, for example, and then you can see that Z is moving. But I'm particularly curious about first of all the cylinder here. So this is a pneumatic cylinder that actuates a hydraulic cylinder. You can see there is end stop, so there's 2 switches here, and typically this is being covered by a panel, but I removed it, and this is the switch that operates it. Now when I press the switch, see, nothing happens. What should actually happen is this valve here should operate, and I can go and there's a override switch here, and I can manually operate it, and you can see that the cylinder works. If I manually operate it, the cylinder works. So the other item is the carousel. So the carousel motor is not working, so I can go clockwise or counterclockwise, nothing is happening. And so this was one of those problems that took me months basically to figure out. But if there is someone I can help, I'm gonna walk you through what I found and what the problem is. So let's go back to the machine. So we are in the back of the machine, and this right here, this one is the computer, and you can see that there are several CAN buses. So here is CAN 1, CAN 0, and then here's an additional one. This doesn't really have name, I call it CAN 2. And what we have here is they are daisy chained. So the power is daisy chained here. There's another cord that goes up and daisy chains these expansion cards. These are basically expansion cards. So what is happening, the computer, when they install these cards, they are all identical, and in order for the computer to figure out which card is which, you know, which is number 0, number 1, number 2, they use little dip switches in the factory to identify the cards. And you can see one of the dip switches here. So I'm going to zoom in on it. So that dip switch is about 8 by 8 millimeters. So right there, you can see the little switches. And as you can see, when everything is assembled on this side, right here, that switch is covered. And this is also covered by the panel. So there is no way to access it. So I'm gonna shut the machine down and take the card out, and we're gonna have a look. Put the fisheye on so you guys can see it clearly. This is the manual from Fryer for the mini mill. It's you can see Fryer Machine Systems mini mill maintenance manual with Anilam 5300 control. So it's got electrical diagrams here in the back, so we can look at the CAN bus, and that's what we have problems with. So on this one you can see there is a press switch here, so tool clockwise push button, tool counterclockwise push button, tool manual push button. So you can see all these are going into the CAN bus, and so these are inputs or outputs on the CAN bus. And again, there are two main CAN buses. There's CAN 0 and CAN 1, and there's an additional one which again doesn't have a name, and these are daisy chained. So right here, these are the power connectors. You can see there's one here and there's one here, and you can imagine if I put another one here, it will be just daisy chained. So we got power, positive, negative, and then this is basically the communication. So the CAN closed area network, something along those lines. You need to tell the computer which one is talking. So there are communication channels here, but only one can talk at the time. And so the coding goes by these little switches here, okay, these little dip switches. I'm gonna zoom in on it, and you can see that it is numbered from 1, 2, 3, and 4. And right here, this one, number 4, is down, and 3 is up, 2 is down, and 1 is up. And actually 2 has to be up, like so. I pushed it down, just I wanted to demonstrate the failure and why is it not working. I need to create some kind of permanent solution for this, because I'm taking this apart 5th or 6th time. This always goes bad, and then I need to go and take it apart and then wiggle this little dip switch, and then everything works. Now if we look at the other two and then this one, so we have CAN 0, CAN 1, and CAN 2. And then the switches are identical because the boards are identical. So if you look at this one, CAN 2, then you can see this is the on, the left side is on. Again, it's got a marking on here. You can see that is on up there. So the left side is on. So if you would decipher this, this would sound like 1101, which is a binary code, and then the decimal equivalent would be 13. Now if you look at this one, you can see all of them are on, so that would be 1111. So that would be a decimal 15. And then if you look at this guy, this would be 1110. So that would be decimal 14. And so you can see there's a logic in it. And clearly I had issues with the CAN 1 because everything that's on the CAN bus was not working. You know, the tool changer motor, the solenoid valve, and so on, they were all on CAN 1 and they weren't working. And so this should be 1110. And so if I turn on 1110, everything is gonna work. So I was thinking about, you know, how to fix this. I can just basically take this switch off and then leave this side connection open and then just connect all 3 of them. You know, just parallel connect these 3. Or I can just soak this in CA glue and then pray that this switch is not gonna move back. I can also put some contact cleaner in it, but honestly I'm sick and tired of taking this apart. Again, this is 5th or 6th time I took it apart, so I think I'm gonna go and just find the traces and wires and then solder it back on. So I'm just gonna connect these pairs together and then call it a day. Well, this is not my most beautiful job, but you can see what I did here as I soldered together these 3 legs, all the 3 that are on one, and here's the other side. So you can see I also soldered together. What this dip switch essentially does, it pulls high, pulls low. This is probably pulls high. So you know, there are some connections to one of these ICs, and it is gonna pull those legs high, so to the 5 volt or 3 volt, whatever the voltage for this board is. So the next thing, I'm gonna put it back together and we'll see how it goes. Sorry for the noise, my phase converter is on. So here you go, machine just booted up. We're gonna go do F10 and then select the software, and then watch this message here, calibrating CAN bus input output network. So you see the error message is gone. So if we see that error message gone, that is good. This is what we want to see, DSP25 motion control board plus 3 nodes detected. Remember I said there are 3 different expansion boards, so they call them 3 nodes. So let's see if any of these things are working now. So the first thing I can test here, see, this is the switch for that. Look at that. See, it's working. I press it and it's basically releasing the cylinder. So the next thing I can do is press the tool changer. Maybe I need to enable the servos. So you can see when the servos are enabled, I'm pressing here the tool changer and it works like a hot damn, whatever a hot damn is. Hopefully it is gonna work from now on. At least I know where the problem is. I can take it apart 7 times and fix it. So signing off from the shrine for the hand-me-downs of the industry. Beautiful representation of a hand-me-down is being resurrected right here in a shrine. See you guys next time. Bye.